welcome back to our system design series, and this is the fourth video of system design series, and today's topic is data model and query language. So this topic is very essential for anyone looking to understand how the data is structured, stored and retrieved in scalable systems. Whether you are designing a simple application or complex application, choosing the right data model directly impacts your system's performance, flexibility, and scalability. So, in this video, we will explore evolution of data models from traditional databases, SQL, NoSQL, and document databases. We will also explore one-to-one, one-to-many relationships, object relational mismatches, and the difference between structured and semi structured data. Okay, so I hope you are very excited to explore these topics, and I will try to make you understand it in very easy manner. Okay, so let's start to understand what do you mean by data model. A data model is a structured way to organize and store data, which helps to define the relationship between data points and makes it easy to retrieve the information as needed. Think of it as a blueprint of how data is stored, connected, and accessed within the system. In a well designed data model, information is logically organized to avoid redundancy and ensure data accuracy. Data models impact everything in a system, from how fast you can access the information to how easily you can scale the application. For example, in the e-commerce website Amazon, the data model might define the relationship between the customers, products, orders, and inventory. And if we choose the right data model, it is easy to retrieve customer history or new orders. However, choosing the wrong data model can make this task slow and complex, leading to the issues such as data consistency and system performance. Okay, so we understood what do you mean by data model and why it is important. So let's explore the different types of data models. So I guess you might haven't heard about this names. First is network, second is XML, third is hierarchical model. So let's explore each of them. First is network model. So it looks something like this, a kind of graph structure where data points are nodes which are connected by the edges, which is representing the relationship between the data points. So each node can connect with multiple data points. You can just see like this, which will enable complex many to many relationships. So this data model will be very useful for the systems such as social media platforms, and second is reservation platforms. Okay, why? Because in this platform the single data items might get linked with multiple data items like customers to flights or maybe restaurants. However, querying on this data models is challenging as it requires specific navigational techniques. So this type of model is less popular today, but it is still relevant for certain applications which have this kind of use case. So in early telecom systems, the banking system were using this kind of model just for like one customer with multiple transaction. Okay, let's talk about the hierarchical model, and it is like a tree structure where each entity have a single parent and multiple children. So this is very efficient for one to many relationships where data retrieval is very straightforward and follows a clear hierarchy. So common use case would include organizational structure, For example, a manager supervises multiple employees, or a file system. So we have the folder, which is inside the folder, which is inside the folder, and which is inside the folder. Okay. So this hierarchical model is fast and reliable for one to many relationships, but it lacks flexibility. For example, if the employee changes the organization, it might move to something another organization. So whole structure needs to be refactored, but still it can be used in this kind of scenarios. And let's move forward to the third one, that is a XML module. I guess you might be familiar with XML module because you might have saw the XML files in your application, where this model structures the data in a human readable format. For example, tags, which is similar to HTML, which makes it highly interpretable. So XML especially is useful for data exchange between the system to understand each other's data. And each XML document have the hierarchy of elements and tags which can nest another text inside it, allowing for structure and complex data representation. So this data model is popular in industries such as finance and healthcare because they follow the strict format of the data exchange. Okay, so these three are not that popular, but are good to know. So let's talk about relational model and SQL. So this topic is quite familiar and you can relate that the relational model organize the data into the table format, where each table represents the entity and column within the table represents attributes. So SQL or structured query language is used to interact with these databases by using CRUD operation, that is create, read, update, or delete. So as it is in table format, it makes it easy to manage the structured data with defined relationships, and which ensures the data integrity through the rules called acid properties. So I hope you know about the acid properties. If you don't know, this is a very important topic you should consider. So acid, A for atomicity, I for integrity, C for consistency, and D for durability. So this data model is the backbone of traditional database systems for decades, and it is widely used in lots of applications that requires complex queries such as financial or healthcare databases. So you might be the familiar with the queries such as select star from table name, or maybe select star from table name where id is equals to 1 2 3 4. This is very useful and I guess you might be familiar with all these things. Okay, so our next topic is NoSQL. So as the web application grow in complexity and scale, it will start facing the limitations if it is still using the relational databases, especially in terms of scalability, flexibility, and performance for the unstructured data. So there comes the picture of NoSQL, which handles large amount of unstructured data, and it is ideal for the applications such as social media or real time analytics and big data. So let me write it, where the data types and relationships changes constantly. So NoSQL database comes into the various forms such as document stores, key value stores, and graph databases. So each of them is used as per the requirement, and we have to study in which situation which data type, and we have to understand this all the databases and in which condition we have to use for specific purpose, and what are the pros and cons of using it. So which applications uses NoSQL, such as Twitter, Facebook, because they have to manage huge amount of unstructured data such as likes, comments, posts, because this data is changing very flexibly and in very small span of time. Okay, so let's talk about object relational mismatch. It is also called impedance mismatch, and it is well known challenge in software development. So it occurs because relational databases organize the data as table format, whereas Java or Python organizes the data as object with properties and methods. So this difference is how data is modeled and creates issues when trying to map between two systems. Okay, so let's talk about OOPS versus relational database. So in OOPS, data is organized as in classes and method format, which makes it easier to represent the real world entities such as customer class with the properties of having name and email. Customer class having properties as name and email. So, however, the relational databases don't store the data as objects, but they store it as an in table format with rows and columns. So, mapping the objects into the database or tabular format is kind of challenging as it doesn't naturally align with the database structure. So, if we want to store the customer property such as name or email ID, it is very easy to store it in the database format. But if we want to store the customer's purchase history, it is kind of difficult because this relationship will require the complex queries, that is joins on various tables. Okay, so I hope you understood this topic. So let's switch to the ORM, that is object relation mapping. So as we saw the problem, and to address this mismatch, we are using the ORM, that is object relation mapping tools, which automatically maps the classes in OOPS language to relational tables in database. So you might have heard as ORM like Hibernate in Java, Django ORM in Python, and Entity Framework in the .NET language, which simplifies the interacting with databases by handling the data retrieval and updates as if we were dealing with the objects directly in the code. So we are usually using the @entity on public class customer and @ID on private ID. So ORMs provides the middle ground by allowing the developers to work with the objects without having to manually translate this into SQL queries. However, the abstraction can lead to inefficiencies, especially when querying on the large data sets. I hope you have understood this topic as well. And so let's move on to the next topic, that is one to many or many to one and many to many relationships. Define how the tables are connected with the other tables or how they are interacting with other tables. For example, one table is interacting with different multiple tables. Many tables are interacting with only one table, or many tables are interacting with many other tables. So this defines how the tables are connected and interacting with other tables. So here, for example, one to many, one row of particular one table is interacting with many other rows of other tables, and similarly the so many rows of one table is interacting with one row of particular one table, and similarly in many to many, so many rows of different tables are interacting with so many rows of or multiple rows of different tables. So here you can take an example of so many students are taking the course of like different courses. So it would be many to many because one student can choose multiple courses, and similarly a single course is been selected by multiple students. Similarly, in many to one, we can take an example of so many orders are ordered by a one single customer, and similarly one to many, one customer have ordered multiple products. Okay, so let's talk about the document database and historical context. So in this module, we will explain how the document database are a response to the modern application needs and the historical context that lead to that development. So first is network model revisited. So document DB resembles with the network model in their ability to represent the complex and interconnected data. So they enable the each document have the nested relationships similar to the node link format as we have seen into the network model. So this allows for flexible and powerful ways to store the hierarchical data structure without the strict database structure or tabular format. So unlike the relational model, document database doesn't require the schemas, making them easy to store the semi-structured data. So each document will have its own data structure. I am just taking an example to make you understand. So you can see all of them have the diverse data format. So in practical scenario, you can consider as that one document is storing the customer's profile. Second document is storing the likes, comments. So similarly, you can take in consider this kind of example. So this flexibility reduces the needs of complex joins, which allows the database to grow and evolve as per the new requirements. So we have discussed so much about the different data models, and choosing the right data model depends on your application's requirement. So in the interview, this is the very important concept, like which database you will choose or which data model you will choose, and you have to answer them as per the requirement. So if your data is unstructured, then choose the NoSQL or document database, depends on the cases to cases. But if your data is structured, then you have to choose SQL. So let's have the quick recap. So we are choosing the relational model when the data is structured and you can apply the ACID properties, and it is ideal for banking and e-commerce. Second is hierarchical model, and you can choose that when you have a single parent relationship, for example organizational data structure or file systems where data can be easily navigated in a tree structure. Then another is network model. It is useful for complex many to many relationships, for example telecom network or social media. Then there is a document model or called NoSQL. It is best for the applications which needs the flexibility in the data schema, rapid scaling, and handling the semi-structured or unstructured data such as big data applications. So ultimately, it is essential to understand each data model's weakness and strength. And nowadays, some of the systems are using the combination of different data models based on the service requirements, often employing microservices to segregate different data storage technologies based on the service requirements. So these were all about the pros and cons of different data model. I hope you have understood this whole concept, and this is a very important concept. I think I will also make the cheat sheet for this so that it would be easy for you to recognize when to use which data model in which situation. So thank you so much for watching this deep dive into data models and query languages. And I hope you found the explanations and the examples helpful in understanding how to choose the right data model for different use cases. And please make sure you like this video, subscribe to my channel, and leave the comments if you have any kind of doubts or suggestions, or you want any particular topic so that I can make the video on that. Check out the descriptions if you want the more resources supporting the information which I have explained, and see you in the next video.